let's figure out the slope of a graph at a given point. So using the difference quotient, we're going to find the slope of the line tangent to the graph of f of x equals 4 over x squared at the point 2, 1. What we're doing here is finding the derivative. Right? The derivative tells us about instantaneous slope. So at any given point, we can figure out what the slope is. And for this one, we happen to be given a point. So we're going to use the difference quotient, find the limit as h approaches 0. We got to figure out what x plus h is first. So f of x plus h, plugging it in for x there, gives us 4 over x plus h squared. And we got to make sure that we FOIL this all out so it works in the end. So x squared plus 2xh plus h squared. And now that we have that, we can go ahead and plug in the function. So f of x plus h is 4 over this, boom, minus f of x over h. This is where people get really scared because they're like, oh, fractions within fractions, what's going on? How do I simplify it? Start one piece at a time. Look at the numerator. What can be done? Well, we can take those two fractions, combine them into one with the common denominator. So I'm going to multiply this side by x squared plus 2xh plus h squared, right? And the same thing in the denominator there. And then over here, we're just going to multiply by x squared over x squared. Let's distribute it out. So x squared times 4, right? 4x squared minus, over here, this is going to be a minus 4 times everything that's in there. Right? This negative 4 is what distributes to every single piece inside this parentheses. So we're going to have minus 4x squared minus 8xh minus 4h squared. And then all over the common denominator, x squared times x squared plus 2xh plus h squared. And then this is all over h. At this point, the stacked fractions, not super pleasing to the eye, so I'm going to move that h. This is technically h over 1, right? When we divide by a fraction, we're multiplying by a reciprocal. So what's happening here is we're multiplying by 1 over h. So that's why I'm going to stick that h in the denominator here. All right, that's going to help me get rid of all of this. Ah, much better. Now we're going to go through and do some cancellations. Well, 4x squared minus 4x squared, boom, equals negative 8xh minus 4h squared over we don't need to cancel every single h for this to work. We just need to cancel out the one that's the problem, right? The one that's the problem is this one right here. And since there's an h up top here, and I got 2 right there, boom, be gone. So then we're left with negative 8x minus 4h over x squared times x squared plus 2xh plus h squared. But we didn't just want the difference quotient, of course. We want to know the limit of this as h approaches 0. So when we plug in 0 for all of the h's, well, this is going to go away, this is going to go away, and this is going to go away. So we're just left with negative 8x over x squared times x squared. Simplifying again, negative 8x over x to the 4th. Simplify one more time, negative 8 over x to the 3rd. And we did it. There's the derivative. One more step, because I didn't just want to find the equation for the instantaneous slope. I want to know what is the slope at 2, 1. So at x equals 2, let's figure that out. f prime of 2 equals negative 8 over 2 to the third power, negative 1. Nice. So that's the slope at this given point. So at 2, 1, the slope is decreasing, right, at a rate of negative 1, whatever the units are.